Good evening. So first of all, wow. I wasn't expecting this many people. So good to be here, and thank you for being at the meetup. My name is Sujee Maniyam. Like Greg said, I'm a founder of Elephant Scale. What we focus on is consulting and training around big data. And so on my way over here, I wasn't sure what the address was, so I pulled up the meetup page to check out where the address is, around 5 o'clock-ish. And then I was really surprised to see like 255 people RSVP'd. Like, oh, okay, this is going to be a good crowd. So I called my co-founder and I said, hey, Mark, did you know, I'm doing this meetup, and it's almost full. And he said, you know why? Because this talk was featured in Hadoop Weekly. How many people here know about Hadoop Weekly? Okay, so okay, so Hadoop Weekly is a weekly newsletter. You go to the website and you sign up. It's a pretty cool way to kind of keep up with the news. So they will tell you about what's being what are the releases, some useful blog posts. So it's a pretty good snapshot of Hadoop and big data on a weekly basis. So I highly recommend it, and not because they just featured me, but it's a truly useful newsletter. All right. So this talk is about moving from Hadoop to Spark, right? So Hadoop, Hadoop seems like it just came out yesterday, but it's actually about 5 years old or even longer. Spark is sort of the newest, newest new darling in the big data world. So I want to kind of quickly get a sense of where the audience are coming from. Can you just show me, do a show of hands if you're using Hadoop already? All right, okay. Good, good. How about Spark? How many people are using Spark? Very good. People who said Spark, how many people are in actually production with Spark? Right, that's what I thought, right? So, and I'll kind of explain why as we go along, right? All right, so very quick intro. Again, I'm not going to waste too much time on the intros because I was told you guys had a Spark talk a couple of months ago. So again, Hadoop. So Hadoop is still the big data platform, right? It's been around for a while and is very well tested. And so the tenet of Hadoop is MapReduce, meaning how do you process data? It's a batch-oriented pipeline, right? So if you look at the Hadoop ecosystem, again, this is kind of the core ecosystem. At the bottom, you have your Hadoop file system, HDFS. And then sort of the processing layers MapReduce. And then Pig and Hive, again, sort of more like we call high-level MapReduce. And Uzi and all the, right? So again, sort of kind of give you a quick taste of things. This side is a batch-oriented system because they are built on MapReduce. MapReduce inherently is a batch-oriented system. So everything built on MapReduce, Pig, Hive, and Uzi, they are batch-oriented as well. On the left-hand side, you see HBase, which is a NoSQL system built on Hadoop. And as you can see, HBase only has dependency only on the file system. It does not depend on MapReduce. So HBase gives you real-time lookups of your data, right? So kind of going over HDFS is the file system. MapReduce is your distributed compute framework. And Pig and Hive are high level. So because since Hadoop is written in Java, writing MapReduce you will end up writing Java code. And it can get pretty verbose and pretty tedious if you end up want to do some pretty serious operations. So Pig and Hive help you out in writing high-level MapReduce. Hive basically takes SQL code, right, and then translates them into MapReduce. And Pig has its own language called Pig-Laden, where you write high-level code and it executes MapReduce. So that's kind of a very quick overview of Hadoop, right? I'm guessing at this point everybody knows Hadoop, so just a quick recap. So Spark. So Spark is basically a distributed compute engine, right? Right now works with Hadoop, and it came out of Berkeley Amp Lab. And even though Spark is just version 1.2-ish, right? I think 1.3 is on its way. It's getting a lot of attention. The reason is, as we'll see, Spark is sort of a pretty unified framework to do batch, interactive, SQL. It kind of, Spark is sort of like Emacs. I don't know if anybody still uses Emacs. It's like, once you are in Emacs, you can check email, you can browse your web, you never have to leave Emacs, right? So Spark is kind of that, right? So Kind of, again, very quick overview of Spark ecosystem. I don't want to spend too much time. If you have any question, please ask me later. So Spark, just like Hadoop, there's a Spark core. Spark actually runs either on Yarn, as in Hadoop, so you can run a Spark on top of Hadoop, or you can run Spark standalone, and also there's another called Mesos. So these are called cluster managers. Then there's Spark core, and then on top of Spark core, we see like a bunch of different components. So Spark SQL, as you would guess, is actually SQL. Just like you write SQL, it takes SQL query and run it on Spark core. Streaming is a very popular approach for Spark. Like for example, if you are looking at data like Twitter streams or like stock ticks coming at you, streaming is a pretty popular framework on top of Spark. And then machine learning lib, this is where Spark's machine learning library is actually bundled. And then finally, GraphX is to do graph processing. All right, again, this is like a very high-level overview. Kind of, so this is kind of what each components look for. So, since I don't work for Databricks, I can tell this pretty confidently. So Spark is getting a huge amount of attention now, right? So I mean, I'm sure you guys are here, and also this is my foolproof way of gauging interest. Anybody know this website, Indeed.com? Right? Yeah. So they kind of aggregate jobs. So as you can see, Spark, up and up and up, right? So, and also here's a couple of benchmarks. And also, if you look at open source point of view, which is active, you can see Spark is pretty active, right? So a lot of interest in Spark. And also, just from just comparing the code, you can see, this is Hadoop MapReduce, like almost, 120K lines, and Spark is, sort of half that. Right? So again, like I said, Spark is a newish project, but it's getting a lot of attention. So quick timeline. So you can sort of, this is year, and then Hadoop on this side, Spark on this side. So 2004, 5-ish, when sort of the Google MapReduce paper came out. And basically, Hadoop is an open source implementation of the Google file system and Google MapReduce, right? So Hadoop kind of came online 2008-ish. That's about 6 years ago. And you can see Hadoop is at version 2 right now, right? We are 2.x. And Spark, as you can see, it's pretty short-lived. Just kind of came in the scene around 2012-ish, right? And then became Apache project. So within like the last couple of years, Spark has come a long way. And because it's one of the most active open source projects. Right? So people ask me all the time, so what's the difference between Hadoop and Spark? Like, which one should I go for, Hadoop or Spark? So if there's one takeaway from this, from this meetup, this is a slide, right? You guys remember this one? Right? Yes, of course we do, right? This is it, right? so just to not to take away anything from the I'm a PC, I'm a Mac ad, so this is the reality, right? Hadoop is proven, but Spark is the new hot thing, right? So, so kind of a quick comparison. One thing that we have to keep in mind is Hadoop gives us both distributed storage and distributed compute, right? Spark is compute only. So basically, you most likely have to couple Spark with some sort of a distributed storage to use it. And we'll see sort of how that works. And Hadoop's compute framework is MapReduce. Spark is a more generalized compute framework. They're a little more flexible than Hadoop's MapReduce framework. And in Hadoop, our data stays in HDFS, right? Because that's a Hadoop file system, as we saw earlier. For Spark, it can be on disk, or more importantly, it can be in memory too. The reason I sort of highlighted in memory is because this is kind of where Spark is really great at. If your data fits into memory, nothing beats Spark, right? And also kind of MapReduce, MapReduce is great for like end-to-end scanning data, aggregates, but it's not really great for iterative work. For example, let's say you have a machine learning algorithm. It has to, let's say it has to iterate like say 20 iterations before it can converge, right? You can do it in MapReduce, but it's kind of, it's kind of painful. There's a lot of overhead. Spark is perfect for these kind of workloads, right? And again, so there's some quick comparisons. Spark is claimed to be up to 10x faster for data on disk, and I'll show you some benchmarks a little later. But the biggest power is if it's in memory, right? That's when you really see the power of Spark. Right? And another cool thing about Spark is right out of the box, it supports 3 languages: Java, Python, and Scala. So that kind of covers a pretty good spectrum, right? Say you're a Python programmer, and you want to do some data analysis using Spark, great, right? You just fire up Spark, write your Python code. You can use all the Python libraries you are used to, like NumPy, Pandas, whatever you guys use. It'll just work out of the box, right? So kind of, so okay, where are things heading? This is kind of, my take on where are things heading. Where Hadoop wants to be, so Hadoop is provides reliable storage, HDFS, and Yarn, which is a cluster management for Hadoop, right? So Yarn is, I think, its point of want to be sort of just like Linux. Yarn wants to be the sort of the universal operating system where we are writing distributed compute on. So Yarn can support, batch process, which is MapReduce, right? Which we had this for forever, or you can run streaming solutions, or like Spark. So the beauty of this is you can just have a single Hadoop cluster and do your MapReduce batch process, do your in-memory compute on Spark, or do your streaming. So I mean, maybe a year ago or even 2 years ago, if you want to have like streaming and Hadoop, what you would have had is you would have had a Hadoop cluster, and then you would have had like a Storm cluster, right? But now, the way things are going, you can have a single unified cluster, and then sort of host applications on top of that, right? So I think sort of that's where we're heading. All right. So why is Spark better for iterative workloads? So on the top, we have a Hadoop MapReduce job. It actually I have like a two-stage job, right? So it goes through one MapReduce and then another MapReduce. So the way Hadoop MapReduce works is it actually fetches data from HDFS. Let's say it goes through map phase and then reduce phase. And then before this data has to be fed to another MapReduce, it has to go back to HDFS. Maybe some sort of temp storage. And then the next MapReduce will pick it up and then do it. HDFS, as great as it is, this is pretty kind of expensive operation, like writing data to HDFS and reading it back. Right? So because that's the way data can be passed from one MapReduce to another. Spark, on the other hand, you can see I read data from HDFS and I do some sort of compute, then I can just keep it in memory and then just pass on to the next stage, which is much faster than sort of going to HDFS and reading it back. Right? So this is why Spark is great for works like iterative workloads, because you can cache your data and then iterate as often as we want. Basically, sure. Question was, should we cache it or can you spill to disk as well? So yeah, so you can spill to disk as well, right? So you can, for example, let's say you're doing something, you want to save it, but your data is just too big to fit in memory. You can easily save to disk and read it back, right? And in this case, you're going to be no worse than Hadoop, but yeah, that's possible too. So you don't have to keep it in memory. Yeah, good question. Yes. Okay. Okay, good question. So question was streaming Storm versus Spark, right? So this is a very loaded question, right? And I'll just say this: Storm was the original streaming solution. It came out of Twitter. Spark is the latest craze, right? So people would argue, so Storm is more like an event-based. Each event goes through, you can process event by event. Spark streaming is not event-based, it's more like batch-based. So what I'm doing is sort of, let's say, but it's what we call micro batches. So it's kind of doing like small batches, but sort of fast enough, so it sort of simulates like streaming. However, even though Storm is pretty granular, Storm, a lot of people will tell you it's pretty low level. Spark is a little more high level. So Spark has things like sliding windows and kind of like high level constructs. So again, this is like two camps. There's no right or wrong answer. So depending on your use case, you could end to choose with Storm or Spark. But Spark definitely has a lot of momentum because it provides like some high level function which most people end up using. Most people never have to go below that, right? So. Yeah, so the question was like, so when you do streaming, there are some of the constructs you have to support, like, exactly once deliver, exactly once compute, right? So again, this is a kind of a huge chapter. What I will kind of say is, let's say a node crashes in the middle of processing, and then the node picks it up. Can you still guarantee delivering events without losing them, right? So there are a lot of guarantees, Storm and Spark, and Spark is getting better at fulfilling these exact once promises, right? So Spark 1.3, keep an eye out. They will come out with some enhancements of the streaming, yeah. Because a lot of people kind of go to Spark for streaming because it's just a natural fit. Okay, again, I know it's kind of a very loaded topic, so I'll kind of skip this one, but I'm happy to talk to you afterwards, yeah. Any other questions on this one? All right, guys, excellent. So here's another thing, right? We said Spark is more generic than MapReduce. It's true, right? In MapReduce, what we see is map, reduce, and then MapReduce. So it's like, map has to be followed by reduce. Look at Spark. Spark, I can just tag and I can do map, and then do cache, and then reduce, reduce, again map. You can sort of mix and match as often as you want, because the programming model is very flexible. So this is why we are no longer sort of have this like a rigid map reduce steps. You can just do map, like I say, I sort of stack 2 maps here and then reduce and then another map. So very flexible programming model. Again, feel free to ask questions anytime. Just raise your hand. All right. So next question I get asked is Spark replacing Hadoop, right? And we do a fair bit of consulting, and so this is something people ask. So should I worry about Spark? Should I skip Hadoop and go to Spark, right? So right now, Spark and Hadoop are complementary, meaning Spark, Spark kind of complements Hadoop. However, the stock is moving away from Hadoop to Spark, right? And we have seen people do this as well. Kind of what we see is, basically my rule of thumb is, if you have small data or small to medium data, give Spark a try. If you have truly large data, you probably want to sort of keep Hadoop around as well. And I'll also tell you guys what do I mean by small data and medium data in a couple of slides. Right? So one of the things Spark is going for is Spark decided, right, they want to be storage agnostic. Right? They don't really, since Spark is a compute engine, remember Spark is compute only, you had to sort of plug in your own storage. So Spark can read from Hadoop, Amazon S3, which is a very popular choice these days, Cassandra, and whatever else. So basically the idea is, once you're in Spark, you don't really care where your data comes from. Your data, you could basically pull data from HDFS, read from Cassandra, do a join, and write to some other, this blue thing, whatever that is going to be. Right? So Spark is trying to be storage agnostic. And that's where we are sort of seeing things heading. Spark trying to be this unified compute platform. Sorry. All right. So I'll kind of so sort of feature by feature comparison between Spark and Hadoop. So batch processing in Hadoop, we will use our MapReduce friends, right? Java MapReduce, Pigo, Hive. In Spark, either you can use basically native RDD. So RDD is basically Spark's data sort of abstraction. So basically you can have like an RDD that talks to HDFS, another RDD that talks to S3. It's an abstraction layer. So in Spark you program at the RDD layer, and all the operations are storage agnostic, right? And querying in Hadoop, we would use Hadoop, Hive. In Spark, we would use SQL, Spark SQL. And stream processing is sort of, it's not part of exactly Hadoop, but these are sort of the 2 candidates, Storm, Kafka, right? And Spark has built-in Spark streaming already. Machine learning, in Hadoop, the library has been out, but Spark is a machine learning lib. So these are kind of sort of direct, direct one-to-one comparison. If you have this in Hadoop, what's the equivalent of Spark? However, if you're using Hadoop for something like real time, say let's say you have deployed HBase deployed, there's no like a NoSQL component in Spark, right? Because that's not what Spark is all about. Spark is not a data storage layer; it's actually a compute layer, right? So if you're looking for HBase replacement, there's not one just yet. Okay. So people ask me, so where do you see this thing going? Spark, Hadoop, who's going to win out? Again, this is my take, right? So I grew up watching Tom and Jerry, right? I'm guessing most of you have too. So these cat and mouse, they're always fighting, but there are brief periods of moment they kind of they'll try to decide to be friends. That's what's going on right now, right? So right now we sort of say not exactly competition, not exactly kind of like they're working together. In 2 years' time, we will see how it all kind of works out, right? So all right. So why do you want to move from Hadoop to Spark? So first thing I hear from people is it's a lot easier than Hadoop. It's true. Spark is a little easier than Hadoop, at least to get started, right? So that part is true. And if you're a data scientist, for example, whether your knowledge is more on the data science front, you don't have to deal with like MapReduce and all this stuff. You just want to like fire up a shell, write some code, and see the result, right? And Spark is really great for that interactive exploration, right? MapReduce is by no means interactive, right? Anyone who has done MapReduce programming at scale will tell you, yeah, man, just fire off something, give it 10 minutes, it comes back, something doesn't work, repeat and rinse, right? We keep doing it. But Spark, things are much more interactive. And another cool thing, people like is the language support. In Hadoop, the native language is, Java, most likely. But Spark, you get Java, Python, Scala, right? So you can pretty much, cover a pretty good spectrum You can find programmers who know Python or Java. Scala is a little hard to find, but Python, Java, they cover a pretty wide swath of programmers. Right? Again, I sort of keep saying, it's great for small to medium data. Again, sort of we'll see what this is. I have a slide coming up on this one. So also, Spark, like I said earlier, is a unified framework, right? Meaning once you go into Spark, you can pretty much, you can do your SQL, you can do your streaming, you can do your, batch analytics, everything, with using one framework and using the language you like, which is a very powerful message because in Hadoop, for example, let's say you have a pig script that's feeding data to Hive. The only way you can join them is sort of, maybe like do like a MapReduce job in pig, and then feed the result into Hive, right? So separate MapReduce jobs. But in Spark, you can within one program you can do SQL and then streaming, so you can sort of mix and match all the programming models, right? Which is very, very powerful language. And again, like I said, Spark is sort of the Emacs, right? I mean, this is the only editor you need. You don't have to go out at all. So, all right. So let's talk about how do we migrate from Spark. Again, this is kind of a recap of what we have seen earlier. From Hadoop, in Hadoop point of view, like we have these components, and we are going to see how those are actually we can do them in Spark. Okay. Any questions so far? This is kind of just a quick background on sort of Hadoop Spark, where things are heading. Now we are going to sort of start looking at, okay, now we decided to sort of move from Hadoop to Spark for whatever reason. What are the things you need to really look for? Okay, I want to sort of cover about 5 topics, data size, file system, and a couple of others. Let's kind of keep going. All right, so remember this is a Hadoop ecosystem. So right now, if you want to sort of replace any of them with Spark, this side is pretty easily replaceable. Again, like I said, there's no no viable solution for HBase yet. But if you want to replace your MapReduce, batch processes, Spark is a pretty good candidate right now. So let's talk about big data for a second, right? So again, we went to Hadoop because we had big data, right? However, the reality is not many people have big data, right? People think they have big data, but they don't really, right? So to me, it's a very simple math. So this is kind of why, how I kind of tell people whether you have big data or not. So I just look for T-shirt sizes, right? So this everyone understands, right? So I have a bunch of T-shirt sizes, right? Small to extra large, and this is how my data fits in, right? So if you have 10 gig data, tens of gigs, you kind of have like a small data problem, right? You don't really have a big data problem, right? And if you have hundreds of gigs, maybe you have a medium data problem, right? And if out here, you're sort of in terabyte range, right? If you're like hundreds of terabytes of data, then you have an extra large data problem, right? So that's kind of how I look at it. So the way we are seeing the adoption is Spark is being utilized kind of in this spectrum. So if you have like a sort of small to medium data, people are adopting Spark pretty readily, right? Because the reason is this data usually can fit in memory, right? So it's a very easy way to kind of load this data, cache it into memory, and do Spark processing. It's very convenient. And this then, sort of if you have like hundreds of terabytes of data, petabytes of data, this is still pretty much Hadoop, right? I mean, I haven't heard of a Spark cluster that's working on 100 terabytes plus data. Maybe there is. I just don't know about it, right? So what we'll see is kind of Spark will slowly scale out, and it'll kind of make inroads here, right? So this is kind of how things are going to work out. All right, so let's look at data size. So Spark, like I said, it's great right here, right? So once you figure out this is my data size, yep, Spark is a recent choice for me. Let's look at how are we going to do the file system. Because remember, Hadoop gives you file system plus compute, right? Spark is just compute. So what's my file system going to be? So in Spark, kind of the 3 popular systems are HDFS. You can still use files in Hadoop, or you can use Amazon S3, or like you can do like a NFS, right? Just like a simple Linux file system, right? So kind of like give you a comparison. Here, you see Spark and accessing data in HDFS, and the cool thing here is the data is local, right? Because HDFS and Spark are co-located, and the machine that's running the compute also has the data locally. So this is pretty cool. So this gives you probably the best throughput you can get for Spark, right? Because your data is local. The next best option is maybe like NFS, right? Let's say you don't have a lot of data, just throw them into like a big NFS server, and then mount them across Spark drives. So you get reasonable data locality. Not data locality, but more like a list of data affinity, I would say. And the last option is Amazon S3 or something, some sort of a cloud storage. You dump data and say Amazon S3, and then use data using Spark, right? And this, you have no data locality at all, right? Because you had to stream data out of out of S3 or other storage. Does that make sense? Sort of the 3 storage choices? Yes. No, exactly. Yeah. So you have a way of loading the data from some source, right? Once you load the data into memory, then you don't have to go to disk. But you still have a way to sort of load the data. And most likely, you want to sort of write the data back as well, right? After processing, you want to save the results. So so you need to have some sort of a data storage backed up to basically read and write data. But in the middle, in the compute, you don't have to go to disk at all, most of the time. Question was, okay, so Yarn versus Mesos. Yarn is a pretty readily adaptable because a lot of people know Hadoop, and then they have experience running Hadoop, so they will kind of deploy Spark. And if you get latest distribution from Cloud or Hortonworks, they will actually you have an option of installing Spark along with Hadoop. So it's kind of easy to install. Mesos is something you have to sort of set up on your own. You need to have expertise setting it up. The projects we worked on, we actually used standalone Spark, right? Because there was no Hadoop in the picture. So I would, if I have to do like a completely kind of guess this, I would say standalone is pretty popular, then Yarn, and then probably Mesos. Again, yeah. I mean, this is not scientific by any means, but kind of from what I've seen. Yeah. Yep.
So is it only S3 or any object storage support like Ceph or other?
Good point. So question was it S3 or anything else? Basically, any distributed file store, right? Basically, because the thing is, remember, Spark is distributed, so your file store has to be accessible from all nodes, right? So if you have a system S3, or Ceph or Gluster, something that's accessible from multiple nodes, that's it. Yeah. So you had a question? Yeah. Right. So the question was for like a small medium data sets, does Spark perform better? Short answer is yes. I'm going to show you some benchmarks too. Yep. Good question. Coming up in 2 minutes. Yes. Good. Yeah. So the question was, can you have like a sort of a hybrid system? I'm guessing with Hadoop and Spark. Absolutely. And you're going to see more and more of that going forward because for example, imagine, and this is part of our use case too, was we had a lot of data, but in any use case, I don't have to go through like terabytes of data. I only had to go through like maybe tens of gigs of data. So for that, I don't want to fire up Hadoop jobs. For that, Spark is better, right? So yeah, so you will have some sort of a hybrid system. Small data set will go through Spark, much quicker turnover, and large data aggregation will go through Hadoop. Like if you're like hundreds of terabytes of data, you would aggregate over. Probably Hadoop is a better choice there too. Yeah. So yeah, yeah. Yes. Good question. So basically, the question was like, if you have like a let's say a cluster with like a small machines, large machines, and so I mean, how does it determine? I believe Spark is capable of kind of dividing up the work. So the machine with more capacity will take up more data. So yeah, so just like Hadoop, the Spark can handle it. However, you don't want to have too much disparity because then your cluster will kind of get out of whack. But yeah, but you can handle heterogeneous clusters just fine. Yeah. Right. Yeah. Cool. Good questions, guys. All right. So we should have showed you guys 3 file systems: HDFS, Amazon S3, and then NFS. Again, so I'm using Amazon S3 as an example. So if you're a Rackspace person, what's the Rackspace file? They have like a cloud something file system, right? So something similar to S3, right? Some sort of a cloud file system. All right. So let's go through some of the points real quick. HDFS, since the data locality, because data is right there on the Spark nodes, right? So I mean, they are co-located, meaning the same machine that's running Spark is also running HDFS. So you get the best data locality there is. And this way your throughput is very high, right? Because most of the time you're reading data from the local disk. Perfect. S3 has no local, right? Because basically you had to stream data over the network, right? So that way your throughput is going to be low. And I have some graphs that are coming up, I'll show you. Right? Latency, again, latency is very low in HDFS because data is very local. Remote file systems like S3 are very high. And again, reliability point of view, HDFS and S3 are pretty high, because we don't hear often like files are being lost on HDFS. Kind of a cost, it's kind of hard to calculate cost in HDFS because it depends on your setup. But on Amazon S3, you can sort of it's basically like $30 per terabyte per month, right? So that's kind of so, and Amazon goes in tiers. This is kind of a reasonable tier starts with. So you can sort of see HDFS and Amazon kind of on sort of 2 ends of the spectrum. If you do NFS, that's sort of somewhere in the middle, right? It's the is a, you have some sort of a data affinity with some medium throughput, right? And you don't have to, you don't have to go through the expense of streaming data, every time, right? So NFS is kind of somewhere in between. It's a happy medium. Yes. Good question. Yeah. So yeah, that's a good question. Was to load data into memory, why does throughput matter, right? It does matter for the initial load, right? Once you load it in, then you don't care. For the initial load, it does matter. And also sometimes, let's say, maybe your data doesn't fit in memory. Let's say you have to keep streaming, or you have to do checkpointing. So in that case, you're going back and forth. Yeah, that kind of adds up, right? But yeah, so if you're just reading it once, storing, caching it, then I don't care. Then I can read from S3, right? Because it's like a one-time penalty. I can pay for it. Yeah, good question. Yeah, I got you. So question was sort of kind of more of a streaming perspective, Storm versus Spark, right? Let me do this. Let's connect afterwards, right? I just want to sort of quickly get through this one. And because streaming Storm and Spark is always a very contentious subject, we'll talk offline, if you don't mind. Yeah, thank you, guys. Right, good. So good question was, in Hadoop, when you do map reduce, data between map and reduce has to be spilled in a disk, and that's usually saved in its local temp space. Spark does the same thing. Spark saves like a local scratch space. Basically, look, when you do multiple data sets and do joining or some sort of a correlation, you have to do shuffling, and that shuffle has to go through over the network anyway. So just like HDFS, Spark also has what we call local directories, local temp directories that just stores temporary data. Yeah, it's the very same concept. Yeah. All right, guys, perfect. All right, so here I want to show you guys two file system comparison, HDFS and S3. So kind of give you a sense of data is about 10 gig, right? So it's kind of a smallish, right? In a sense of overall sense of things. I had 10 files, each file is about 1 gig. So the files are pretty large, right? And these files are like plain CSV files, about they had about 400 million records. And I'm testing this on a cluster, which is like an 8-node cluster. And people who are familiar with Amazon, these are like M3X large. So there are a lot of memory. You can see like the machines have 15 gig memory each, and also these machines have flash drives, right? For my Hadoop cluster, I have Hortonworks, latest Hortonworks 2.2, and Spark. I'm using Spark just standalone, right? Just so and latest 1.2. So 8 nodes running Hadoop and Spark side by side, right? So what we're going to do, I want to kind of do a quick benchmark of my data throughput from HDFS and S3. And in Spark is a very simple way to do, right? So I'm, as you can see, basically SC stands for Spark context. So I'm creating a pointer to a file in HDFS, something to a 10 gig directory, and then another pointer to another file in Amazon S3. Right? And then all I'm doing is I'm just doing a straight count. Count is basically very simple. Go through the entire file and tell me how many records are there. That's it. It's the simplest thing you can do, right? Count. So I'm doing counts in HDFS and S3. Right? So let's see if I did S3. Sorry, if I did HDFS, you can see right here. So kind of to read 10 gig is about 16 seconds. So the Spark went through 10 gig of files, reading from HDFS in 16 seconds. Let's see how much time it took from S3. You see that? So it's like 16 seconds is like way down here. It's almost like 20x time it takes to stream data from S3 into Spark. Right? So the reason I'm showing you this is like you need to be aware of this these issues when we are sort of figuring out, hey, what's my file system going to be? Should I go with HDFS? Should I go with S3? What are the implications, right? You definitely have a lot of, HDFS is much quicker because data is co-located with Spark. S3, you have to stream data out, so it just increases, right? And again, this is just like a couple of benchmark runs, so there's always somebody going to say, oh, did you set this setting? No, everything is default, right? So it's just the default settings. Yes. Yeah, so that's a good question. So question was, what about NFS? Unfortunately, I don't have an NFS number. I'm guessing it's going to be somewhere in between the throughput, because NFS, remember, still one machine serving the files, right? But that machine is, the good news is it's not as remote as S3, right? The machines are most likely co-located in the same rack or something, so it will have much higher throughput. So NFS, I'm guessing, again, I haven't done this in an NFS experiment, it'll be somewhere around here. Good point. I think.
Maybe joking on the bandwidth.
Yep. Yeah, so I mean, so HDFS, these are like, co-located. S3, I think these machines have I think they have like a 1 gig interconnect, I think, 1 gig. Yeah, I need to check the specs for the Amazon machine type, but I believe they are 1 gig. Yeah, good question, yeah. I mean, because yeah, network comes into play too, exactly, yeah, yeah. Sorry, yeah.
And HDFS is on the same node, so where you have SSD drives. So essentially, HDFS on SSDs, right?
Right. So again, and this gets pretty complicated. So the question was like, NFS, HDFS, rack location, and all these things come into picture. And in reality, doing a real benchmark, I mean, you have to sort of make sure machines are on the same rack. Yeah, it gets pretty complicated. But this is kind of like a sort of a back of the envelope benchmark, right? Just to sort of give an idea of, hey, if you spin up a bunch of machines in Amazon and do like a quick benchmark, right? Can I get a feel for what it is? This is it, right? Yeah, that's it. Yeah, so don't, yeah. So take it with a little bit of, yeah. Oh. All right, guys. Yes. Right. So the question was, you'll get better throughput if it's a distributed file system. Not just that, distributed and co-located, right? I mean, basically, the data has to be kind of, this is the best case scenario. If your data is already residing on the same nodes, this is the perfect scenario. But that's not always possible. Right? Hence S3 and S3. Yeah. Excuse me, yeah. So the question was, if we were to co-locate, say, Hadoop and Spark, I'll just take the Hadoop and Spark, for example, right? Because,
Hadoop is easy because it's yarn.
Right, actually, yeah. So good point. So actually, in this test, I have Hadoop and Spark running, but Spark is running standalone, not as a yarn. Spark is running the same node, but not on yarn, standalone. In Cassandra, you will most likely end up doing standalone, right? Because if you want to do yarn, then you have to install Hadoop as well, right? So in most of the cases, you want to minimize the moving parts, so we'll kind of do like just Cassandra and Spark, yeah. And because this sort of gets into sort of more like a DevOps kind of a thing, right? Yeah. Excellent, guys. Yeah. Right. So so question was like, how do we run Spark on AWS S3? So this is kind of like a very basic run. When you set up AWS nodes, there are all these network settings you can sort of figure out and optimize. And then you probably want to do that. If you want like a stand-up, permanent cluster, you want to make sure the machines are co-located. They're not scattered all around. So Amazon has things called zones, and then within zone they're like something else, right? So exactly, A, B, C, and all that stuff. So you want to make sure your machines are at least like together, right? They're not like scattered out. Yeah. So and these machines are, yeah. So all right, guys. So conclusion. So what do we see, right? So HDFS is great. Right? I get perfect throughput. It's great. However, if this is great, why don't we do it? Because I need to maintain HDFS, right? Because if I'm running Spark at HDFS, I have to kind of install, and run and maintain Hadoop, at least the HDFS layer, for this to work. S3, there's nothing, right? I just read from S3. There's nothing. No, I'm not running any daemons. I just point to S3 and then read it right out, right? Pretty simple. So this is kind of like a convenient trade-off between performance and convenience, right? So whether you want the performance, then you probably go with HDFS. If you just want the convenience of, look, I don't want to go run, install, and set up Hadoop. I just want to read from S3. I can deal with the latency, right? S3 is fine, good choice. Okay. However, there are a few cases.
Build your own object store, and then use this.
Spark to access it. Okay. Yeah. Okay. Yeah. So a question was like, how about like I come up with some other file store, like Ceph or Lustre or something? You can, and you want to kind of check how they expose the data, right? And most of the time, Spark can read them right off. If they just mount as like NFS, Spark can read them right off. Or maybe you need like some special adapter, like Spark and Cassandra has a special adapter, right? So you want to check that.
S3 compliant APIs.
Okay, so if Ceph looks like S3, yep, exactly, yeah, right? So you can read from Ceph. And I think Ceph also mounts as just NFS, right? I think they support NFS v4.
It depends on how you are storing the data, whether you are storing a file, block store, or object store.
Okay, yep. So check how they interface. If they mount as a regular file system, then use regular file system APIs, or you need to have like an adapter so Spark knows how to pull data out of the file system. That's it. Yep. All right, guys. So file system. So we're done with file system. Next, I'm going to say, okay, yep, I solved the file system issue. Now processing. I want to sort of see SQL, right? Let's say I'm a big Hive shop. I have lots of Hive queries. How feasible it is for me to move to Spark, right? So let's take a look at that. So this is a quick comparison between Hive and Spark. Good news is Spark natively understands HiveQL. And also, another beauty is Spark can actually read Hive tables natively. And they both support like pretty common format like JSON, Spark A, all the formats are supported right out of the box. So Spark, the fact Spark can read Hive tables is a pretty good deal. I'll show you guys a quick example how this is done. Right? So imagine, let me say this is my data. Let's say I have a CSV data. Let's say this is like a CDR record. CDR is like a call detail record. Like let's say every time you make a phone call, your telco will log the call, right? And I don't know how many people do this. When you get your phone bill, take a look at your phone bill. It's almost like a bunch of pages. The first couple of pages will be like a summary. Then, if you look at the last few pages, it'll be every phone call you ever made. Right? I don't know if anybody kind of know this at all. It used to matter because we used to pay for per minutes, right? But now everyone has like unlimited minutes. We don't really care how many minutes we use. So in your phone record, every SMS you send, every phone call you made will be logged. Right? So imagine this is a log like this, right? For example, I have a customer 1 made a phone call that lasted 10 minutes. That cost them 10 cents, right? Customer number 2 sent an SMS, right? And then that costs them 4 cents, right? So every time I do a transaction, my transactions are logged. So what I want to do is, like, let's say I'm collecting this, and this can be like billions of records, right? Imagine somebody like AT&T, which is like, say, 100 million plus customers. Every one of us do like, 100, 200 transactions a month. It's in billions, right? So let's say I have all these records, billions of records like this. I want to do a Hive query to find me my top 10 customers, meaning find me the customers who spend most money with us. Maybe we want to do a promotion, maybe we want to give them a discount, something, right? So I want to find top 10 customers who basically spend most money with us. So again, the data set, same data set as I showed you guys earlier, 10 gig plus, about 400 million records in this format. And there's a simple CSV file. So so just do a quick show of Hive, right? So what you would do in Hive is, first thing you will create a table. And again, I'm not going to go too much in detail, but you create a table for the CSV file. And then basically, once you have a table, this is a query. This is a query, we all know, right? It's a basically aggregate query. I'm querying by customer ID, and I'm ordering by total, so I get my top 10. Right? Very simple SQL. And in Hive, this is just as easy. All right, so I did this Hive query. It took me about, about 9 minutes or so, right? Again, it's a small cluster, right? Same query I'm going to do in Spark. Here's the beauty of Spark. You can see Spark can natively read Hive tables, right? So here, I'm actually initializing a Hive context, and I'm plugging in the exact same query as I did in Hive into Spark. And that's it. That's all I had to do. Spark will natively go and read the Hive tables and process the data. Right? So I run the query. So I say, top 10. This is my query, and then I print the top 10 out. Response time. Right? So mind you, this is from the exact same HDFS data. Right? Hive is reading from the same HDFS. Spark is reading the exact same HDFS as well, and you can see how effective Spark is executing the query. Right? So this is why we like Spark. Because even for the same queries, for the same data in HDFS, I run much, much faster.
Can you compare with Impala or something like that?
Yeah, so Impala will be definitely quicker than Hive, right? Definitely, right, because that's Impala's strength. I don't have numbers for you, though. I'll check out Cloudera. I'm sure they do this comparison all the time, Impala versus Hive, Impala versus Spark. I'll check it out, but I don't have numbers for you. But Impala will be something pretty close to Spark SQL, I would imagine. Yep.
How would that look if we had more data?
Good question. So the question was, what about instead of 10 gig, right? Because that's all the data I had. What if I had 10 terabyte, right? Because remember, part of the reason is MapReduce has a lot of startup costs, right? So if you have more and more data, your startup, the overhead kind of get amortized a little bit. So then, then Hive will be a little more competitive, right? Because you're kind of you're sort of amortizing your spin-up cost and maintenance cost across large volumes of data. And and then maybe Hive and Spark will be pretty close, but still maybe it won't be like this. I think Spark will be still quicker, but it won't be this. It won't be this huge of a gap. And hence again, so this goes to the exact same point. Hadoop excels at really large scale of data, right? If you have like hundreds of gigs of data, just way too much overhead in Hadoop.
Is Hive smart? Is the Spark SQL smart enough to spill out the disk
It does. Yeah, it does. Yeah. So I mean, sort of the underlying engine is pretty much like a sort of they sort, they shuffle, they move things around network. Exactly. Yeah. All that happens a little more effectively, right? As we can see, right? So sure. So let me sort of paraphrase. Your question was like, if Spark has to spill to disk, would it be slower? Here, it is actually spilling to disk, right? I mean, I see. I mean, when I run this, I sort of see, files being transferred, and they can sorted and shuffled, and then Spark will write to temporary space in the middle, right? Yeah. So Spark is kind of writing to to temporary space as well, but here it's a little more very effective algorithm, right? So that's why it's faster. Question. Okay.
Does Spark also do like speculative executions like
Question, yeah. Does Spark does a speculative execution? Yes, it does. Basically, what it is like, when Spark detects a certain node is being slow, it will launch duplicate tasks on other nodes, and then whoever finishes first is the winner, right? So the reason it's done is, in a distributed compute, one node can hold up the entire compute, right? So you don't want that to happen. So what you do is you sort of, if a node is being particularly slow, Spark will launch duplicate jobs on other nodes, and then see who, it's like a little race, right? Let's say who finishes first. Yeah. So long answer, but yes, answer is yes, yes.
So why is Spark faster here? Because it's keeping everything in memory? Is that
Good question. Why Spark faster? Yeah. Again, very loaded question. So Spark does really well on small set of data, right? Because the way the code is written is very different from MapReduce, right? So Spark gains a lot by doing a sort of small subset of data. In terabytes of data, this advantage might shrink a little bit, but I think overall Spark is still faster, just because the way the engine is written is very different than MapReduce.
No, but that's all just. So if this is this much slower, is it because there's more I/O in Hive?
Right, because remember in Hive, data transfer has to go through HDFS, right? So one stage of MapReduce happens, before the next stage picks up, it has to go to HDFS and come back, right? So that is pretty expensive. Yep. And again, so that's why the engine is inherently very different. So they can handle the data handle very, very differently. So I'll sort of stop right there, and I'm happy to talk to you afterwards. Yeah.
Is there, for Spark scalability, is it a challenge scaling horizontal more because of technology or cost? Like if I had petabytes and I wanted to get 1,000 EC2 nodes or some silly large number.
Yep, good question. So Spark and scalability, right? It's a very young platform. So yeah, I mean, again, I haven't seen like 1,000 node Spark cluster. At least I haven't heard of it. But I'm sure, as time goes along in a couple of years, you will see that. Yeah. So it's just a maturity of the platform. Right now, it's pretty small clusters. What we done. Yeah. Right. So there are a couple of initiatives going on. So it's not a secret that Hive is slow. So Hortonworks has an open source project called Tez, T-E-Z, that's supposed to speed up Hive. And also they're working on, basically, what Hive is sort of like a, Hive needs an engine, right? So the engine could be Tez, which is faster than the default engine, or Spark, right? So they're kind of figuring out the way to sort of plug it in. So your Hive runs as it is, but you just use a different engine. That engine happens to be Spark. So that's the project is all about. Yeah. All right, we're going to move on. Yeah. Good question. Yeah. So as a programmer, which is easier to kind of develop cycle, right? Spark is much more friendlier than just because I'll show you a couple of examples. Just because it's very fast iterations, you can figure things out pretty quickly. Yeah. So Spark is easier. All right, guys. All right. So conclusions again very quickly. Look, I mean, if you are using Hive already, you can give Spark a try because Spark can natively read Hive tables. You don't have to kind of re-import, re-export the data. Just keep the data in Hive tables, fire up Spark, and just do some queries, right? So just try it out, see how it goes. And also, as you can see, I mean, if you want to sort of do queries, this Spark is much more interactive because your queries come back to you very quickly. And also, let's say you don't have Hive. That's okay too. What we can do is we can actually Spark can actually load all these data formats, CSV, JSON, Parquet format natively, and then sort of treat them as like a table, right? So you don't have to have Hive running to use SQL. That's the beauty of this, right? I mean, so to use the SQL, I mean, here I'm using Hive context, but you can do almost the same thing with Spark native SQL. It has no dependency on Hive, right? You can load data natively, and then you can just do this exact same SQL query. And that's another strength of Spark. If you have Hive, great, it'll work with it. If you don't, that's okay too. You can load data on your own and then do queries. Okay, very good, guys. Okay, very quickly, next step is ETL. How do we do ETL in Spark? So what is ETL? ETL is basically, when you get your data, it's in some format. You need to sort of maybe clean this data, right, and create another data set. And then you sort of join this data set with another data set and create another data set. So your data kind of goes through a bunch of phases before it becomes queryable, right? Because your raw data, which is this one, is hardly in a form to in a queryable format. So you can have to go through multiple stages to clean up and merge data, join data, to bring it to a format that's queryable. So this is usually called ETL, right? Extract, transfer, load, a very old concept. So let's say in Hadoop, your ETL tools are usually pig or cascading, right? Is one of the popular tools. In Spark, you would use as like a just plain RDD program. Just you will treat the data as data sets, and then just write Java, Python, Scala code to do processing, right? So pig is a very popular tool for ETL. There's a open source project called Spoke, so kind of a weird name, runs pig on Spark. So if you have lots of pig scripts, you're like a very big, in a very huge pig shop, and you don't want to go and rewrite all the pig scripts in like native RDDs, no big deal. Now work is being done on pig, so pig can actually execute on Spark, right? And also if you do cascading, if you're a cascading shop, there's another project called Spark Scalding, which basically takes scalding programs and runs on Spark, right? So if your ETL is kind of tied in pig or cascading or scalding, there are projects that kind of enable you to just plug it in and then run it on Spark, right?
But usually there is a scheduling. It's nothing to do with ETL as such, right?
Right. So
do you have any scheduling in Spark?
no, not at least not that I know of. So yeah. So the question was, Uzi is more of a scheduler. You are right. So Uzi is one sort of let's say I have 2 pig jobs and then 2 Hive jobs and another pig job. How do I going to assemble them all together? I'll use Uzi, right? And I don't know if like a Spark equivalent of Uzi just yet. Right? Yeah.
Can you use Zookeeper or something?
Zookeeper is more on the lines of like for like to run like highly available system. Like for example, Spark. You have a Spark master. You don't want a master to be a single point of failure. There you will use Zookeeper, but not for like not for like workflow management, right? Yeah. So just to kind of quickly, so once the pig port is complete, running pig on Spark is as simple as saying minus execute on Spark. Like when you launch pig, you say minus x Spark, and then and then that's it. And the pig will actually use Spark engine to execute your pig script, right? So and this is work in progress. The guys who are doing this as a company called Sigmoid Analytics, and they actually have open source thing, but they're trying to merge this into a pig mainline. Right? Same in cascading, right? So cascading, scalding, same thing. Tresata has a scalding plugin for Spark. Just run scalding scripts on Spark. So ETL, if you have pig or scalding, try one of these plugins. Or a lot of people we are seeing, they just prefer to write native Spark programming. They will just say, let's just work on RDD level. They will just write RDD transformation in Python or Java because it's native. There's no dependencies. And some of the times it could be even faster and more flexible, right? Because remember, this is just generic programming. You can pick up any language you want and just write RDD programming. And we see this more and more. Okay. Yep. Good question. So the question was, Spark is written in Scala, true. Is Scala kind of like the preferred language? Not in the performance sense, but you will find Spark and Scala are a very good fit. Because it's very compact, very effective. A lot of the RDD program we will see like Scala because it's just a better feel for the language. But performance-wise, because at the end of the day, Scala gets converted to JVM code anyway. So runtime, I don't think you will notice a difference. It's just your productivity, right? Because Scala is a much more concise language and it's a pure functional language, right? So it's a little nicer to program than Java, right? So, but the challenge is it's a steep learning curve. Scala is not very easy to pick up, right? It's a very dense language, so you can have to spend some time kind of mastering it, yeah. So, all right, guys. Finally, machine learning. So this is where Spark really excels because a lot of the machine learning, remember, it's all about a lot of the machine learning algorithms are very iterative. So let's say you do iteration, you do a little bit of converge. Then you start from there and then do another iteration. As long as your data points, your solution has to converge. And this is perfect. Why? Spark. I'm going to load my data set in memory. And then once it's memory, then it's in-memory compute. You can write, you can write as many iterations as possible, right? It just runs very quickly. And also, don't forget language support, right? You can write in, Java, Python, Sky. I keep saying this right now, but the thing is, let's say you're a Python data scientist, you'll be right at home in Spark, right? Because you can just use the existing libraries like pandas and scikit and everything you're used to just here. Right? Very, very convenient. So this is kind of why a lot of data scientists prefer Spark, right? Because much easier system to than Hadoop to get going. Right? And again, we have seen this before, right? Because why Spark is great for iterative is right because it has a in Hadoop data has to go up, come back to HDFS, and then it has to be right back. In Spark, you can sort of do compute and keep the data in memory, so it's much faster. Right? That's why Spark is great for.
Mahout is totally ported to Spark.
Yeah, Mahout is So Mahout, Mahout was great in the Hadoop land, but I think now they're merging with Spark.
They're not accepting any Hadoop.
Yeah, which is not surprising to me. Yeah, because it's a natural fit. Spark it's a very very good fit for machine learning and data science. Just because it's very fundamentally different. Yeah, I'm not surprised. All right, guys. So caching. So again, I want to kind of emphasize how quickly caching is because as we saw, reading from S3 or something can be very slow, right? And if you keep reading this over and over again, and you're paying a performance penalty. So let me kind of show you how effective caching is in Spark, right? So let me kind of show a quick demo. And against my own judgment of not doing live demos, let me give it a try. All right, so I'm connected. All right, yep. All right, good. Can you guys see this okay? Very good. So here's my Spark cluster. Right, I have 8 nodes. My Spark. This is a Spark master. I'm running, running 8 nodes. So I'm going to launch a Spark shell. Let me kind of maximize a little bit so you guys can see this better. Is that better? All right. All right. So I'm launching a Spark shell, and this is the sort of interactive shell of Spark that gives you. You will see how effective it is to use. Basically, what I'm doing is I'm connecting to the Spark master I already have set up, and also I'm sort of giving it more memory than it needs. So I'm giving it like 6 gig, for on each node, right? So let's get it going. There you go. Ta-da, there we go. So now I'm at the Spark shell. Let it settle down. So this is actually Scala shell, so you can do this. Not very exciting, but it does work, right? So it's actually a Spark shell. Scala shell. All right. So now, if I can show you guys, in here you see my Spark cluster and also my application I just launched the Spark shell. Right? So you can see all the stats. It has like 32 cores allocated to it, and each node has 6 gig memory, all the cool stuff. Right? And also, the cool thing is there's another UI for the actual shell. So shell actually puts up another UI, and right now it's empty, right? I haven't done anything yet. All right, so let me kind of bring up my script. All right, so what I want to do is I want to read some data from Amazon. All right? So first thing I want to do is I want to point to this file. This is about let me just make it 500 meg because otherwise it will just take way too long. So I'm loading a 500 meg file from S3. Right, so let me load that. That's it. Now this one pretty quick. Did it actually load the data? No, right? It's just a pointer. Until I actually do some execution, it's not going to load any data, right? So I kind of want to take some numbers. All right, let's say this 500 meg file. So let's see how long it takes. So what I'm going to do is I'm going to ask Spark to actually just go through the entire file, the simplest way to do that is just do a count, right? So I'm going to say count, right? Count the file. And as you will see, you'll see lots of logging. What you will see is, if you go to the UI, while the job is running, as you can see, there are 8 tasks that are scheduled for this. And as you will see, right, so when I hit refresh, right, 7 tasks are done. So it's kind of doing it in parallel, right? So it chops the 500 meg file into 8, 8 partitions, and then going through them in parallel. Right, almost done. Right. So let's see. Yep, so done. All right. So it took about 33 seconds. All right. So that's my 33 seconds. All right. Let me do it one more time just to be sure. All right. So again, same thing. You will see it kicks off another job, right? Again, it's a 8 tasks and executing in parallel. All right. So this one came back a little quicker. So 17 seconds. Right. Again, so this is executing the cloud. There's IOs and all the stuff comes in. But yeah. So around kind of let's say this is the right one. 15 seconds. Let's take that. So what I want to do is right now, I want to actually cache this file. I'm telling Spark, cache this data. File is cached, right? So let's go and do another count. So I'm expecting this to be lightning fast. Let's see what happens. All right, job started. Can I go back and do a refresh? 6 seconds already. Doesn't look very promising, does it? I asked Spark to cache it. It's done. So again, 13 seconds. All right. Not a huge improvement, is it? Just to be sure, let me run the other one. Just one more time. Count again. Aha. 0.3 seconds. I know you guys can see this, but it's sort of somewhere right here, right? So what does it prove? You can see the difference in caching, right? I mean, caching, just a fraction of a second. I mean, basically, caching is literally, sub-second to process 500 meg of data. So can somebody tell me why, even after I said cache, it still took 13 seconds right after cache? Exactly. So just because I said cache, Spark doesn't do cache right away. It sort of defers caching until we actually force it to cache, right? So the first run after the cache still has to read the data and cache it. So that's why, even after the cache, I did cache right here, but still it took like, 13 seconds or whatever, right? But then you see it, right? I mean, now it's really cached, sub-second responses. This is what's great about Spark, right? I mean, if this is 500 meg, if you put 1 gig of data, it'll still be sub-seconds, right? Because it's basically in-memory processing. Does that make sense? Cool. Okay, I'm really glad that worked out. Yeah. So, the question was, how does Spark manage caching? Yeah. So Spark will evict cache partitions. Like I think it uses like a LRU algorithm, least recently used. So it will sort of evict the old ones, right? It's configurable, yeah. So you can, yeah. And so this is kind of a backup plan in case my demo didn't work. Right, so this is the graph. Anyway, so now, but the demo worked, so we're all happy, right? So, okay, great. All right, so now that I show you got caching, so caching is great, right? I mean, this is what I want to learn Spark. But here's the bummer. Caching, I cannot share the cache data set across multiple applications. Let's say somebody write one application, I cache the data, great. I execute like in less than a second, fantastic. Next guy comes in, runs his application, my cache is not visible to him, right? Because Spark actually executes each job in a sandbox. So whatever cache data I had is not visible to the other guy. So this is kind of a downer, right? Because the caching is great, but I can't share caching. There are a couple of options you can do. So what we need is some sort of what we call a multiplexer, right? Meaning one guy to execute all the jobs through one context or one Spark connection, right? So this way, all the jobs go through this guy. Right, so it's like kind of a multiplexing effort, And this way, my data is cached across all the applications. So this is what we call something called Spark Job Server, meaning a standalone server that kind of intercepts the client request and funnels them through its own connection, so data can be cached effectively across multiple clients. Does that make sense? So, and you will see, you will see sort of, there are, at least I know a couple of Spark job servers that came about. Pretty soon, I think this will eventually make it into Spark itself, right? Because this is a huge need. Because people say, hey, you know what, caching is great, I want to use it. I want to use it across all my application. So probably some sort of a light job server version will make it into Spark. The one I worked with is open source from Uyala. It's actually called Spark Job Server, surprise, surprise. So basically, it's basically, the cool thing is it does what we call Spark as a service, right? So now this job server, it exposes a very simple REST API where you can submit jobs. Pretty cool stuff. And it sort of establishes a connection, and everything is primed, ready to go. Your jobs come in, and then they execute in sub-seconds. Right? Very, very effective. And there's a GitHub page. And the way they share cache data is when I cache my data, I gave it a name, right? Just any name. And then another application comes in, and then he can read the same data back, and it'll be cached. Right? Because why this works? Because I have only one connection to Spark. Right? Perfect. Any question on the job server front? Okay. Another option is something called Tachyon. So Tachyon is basically an in-memory file system that is coming out of same Berkeley lab that Spark came out of, AMP lab. So think like HDFS, but your data is in memory, backed by disk. Right? So now your data is in cache permanently, right? I mean, you load the data, it's actually cached. So your access is very quick. So, and Tachyon is, kind of like it's not a 1.0 release yet. It's pretty early days, but yeah, I mean, you can be sure since they came out of the same lab, they will have pretty good integration. So Spark, if you want to do caching, we'll probably either do like a job server like this, standalone job server, or maybe like caching everything in Tachyon and launching Spark jobs. And remember, if you use Tachyon, there's no need for intermediate job server, right? Your clients can straight away connect to Spark, and everyone will see the data that's cached in memory. Right? It's a shared memory cache. Yep. Right, because so the question was like, then what happens? How do you, HDFS and all that? Yeah, basically now you're sort of reprogrammed. Basically, that you sort of leave that behind and program for Tachyon, right? But the cool thing in Spark is you don't necessarily have to worry about where the file is stored. You sort of, if you program at the RDD level, you don't really care where the data goes, right? Maybe there's some initial setup you need to sort of take care of for Tachyon specific, but other than that, then that's it. You say RDD, some operation, save, load, everything kind of comes out of that pretty abstract level. That's the power of Spark.
But that can read from HDFS.
Absolutely, yeah. Right. So thanks for pointing it out. Exactly, because remember, Spark is sort of storage neutral, right? It can plug into any storage. So maybe you can read from HDFS and save it to Tachyon. I mean, yeah. So all sorts of things are possible. There was a question over there. No. So sorry. Okay. So Tachyon, what is Tachyon? Basically, Tachyon is like it's a in-memory file system. It's actually backed by disk, right? So when you write files to Tachyon, they're stored in memory. Also, is stored in disk, right? So in case like one node crashes, your data is still safe because it's persisted to disk. But when you read a file, your files come from memory very, very fast, right? So think like. Sure. Okay. Yep. So yeah, kind of like a buffer cache, but think at a very large scale. Like basically, exactly. Yep. So that's the way to think about it. There's a question around here. Yeah. How about flash drives, right? SSDs and flash drive. What you will see, and this is not Spark specific. This is kind of the whole, storage specific. Solid state drives will serve as some sort of a memory, right? So basically, you will buy like a 1 terabyte memory, quote unquote. Only 100 gig is actually RAM. Other 900 gig is actually a solid state drive, right? So the whole thing will look like a 1 terabyte memory for you, but the drive will actually shuffle data in and out for you. And I think there are drives already there that does this for you, right? So this way actually you're getting much more capacity. Maybe like you're taking a slight performance hit, right? Does that make sense? Yeah. So and you'll see Hadoop and Spark kind of adapting for this kind of a hybrid storage system, like memory backed by disk, and it's simply the future. Yeah, it's going to happen. Yep. right? So Spark and security. Anyone here work on Hadoop and security? Secure Hadoop, security? So it only took Hadoop 5 years to have decent security, right? So Spark, maybe 3 years. No, so don't quote me on this, because yeah. So, but a lot of the lessons, one of the things Spark people are doing right is, they're learning a lot of lessons from Hadoop, right? Because Hadoop was the first truly mainstream distributed computing system, right? So Spark took a lot of lessons from Hadoop, and yeah. So so you will see something. Right now it's a simple security model, like just a file system level. But I wouldn't be surprised to see more elaborate security pretty soon. I don't think it's going to take another 5 years to have Spark security, right? So anyway, so we sort of joke in Hadoop and security, it's always next year, right? I mean, you say, how is Hadoop security? You're like, yeah, we'll have it next year. It's always next year.
Is Tachyon going to be an Apache project?
I think it already is. So Tachyon is already an Apache project. Or maybe incubator or something. May not be top level, but yeah. All right, guys. So now that we went through all the sort of scenarios, I want to quickly talk about a quick case study, and I know we are getting close to close time. So this is the kind of this is why did we do all this research is basically of this project, right? So we have this project. The project was each client will log into our system, and each client has to analyze about a few gigs to tens of gigs of data, right? But as overall, there could be terabytes of data. But each client has to only sort of deal with his own data set, a few gigs, maybe hundreds of megs, depending on the client, data size, right? So original design was they log into the this web application. They say, hey, here's my data set. Now run this algorithm on the data set, right? So basically, what that's done is actually queued as a MapReduce job. We actually queue the MapReduce job in Hadoop. Right, and it will go and run after takes 5 minutes, 10 minutes, whatever. It'll come back and then say, hey, here's the result. Right? So it's kind of pretty slow, right? Because MapReduce is inherently a batch system. And that was it, because that was the only thing we could do. Then we sort of looked at this one. We said, hey, wait a second, Spark. I'm not crunching terabytes of data. I'm only crunching maybe at most a few gigabytes at a time. Why don't I use Spark caching, right? Because I just showed you guys how effective caching was, right? So what we did is our data is in S3. It's actually loaded to the Spark cluster and cached. And this is like a one-time thing, right? Remember, because I only have to cache once, and that's okay. If you incur some streaming penalty, that's okay because it's like a one-time thing. And then I have a Spark job server in front of me, and it's intercepting all the web requests and executing the code on Spark. Very, very fast, like sub-seconds, right? We just saw that, right? Sub-second execution times. So when a client submits the queries, it actually looks like a web application. Right? They click a button, say submit, see a little spinny wheel, and 3 seconds later, results comes back. Pretty cool, right? And this is kind of new, but the reason I sort of, I like this model is this model we haven't seen before. If you think back to sort of the big data and the sort of applications, a lot of the real-time results you will see are either some sort of a streaming result, so you sort of see the latest snapshot, or they would have computed something in a way in advance, right? Maybe you only see sort of the pre-computed results. Doing this on the fly on sort of medium data is something new, right? Doing some number crunching on hundreds of gigs of data, or not maybe hundreds of gigs, maybe tens of gigs of data in few seconds. This is kind of new. Only it's possible with Spark, right? You can think back to any Cassandra, HBase, and everything. I can guarantee you it's all most of the data is pre-computed, right? But with this, you can actually run jobs right on the fly with sort of a small subset of data. Does that make sense? Yep.
So in terms of data size, how's that calculated? What 100
Right. So how do we calculate the data size? Yeah, good question. So it's basically each client, they accumulate their own data set. So as each client logs in, they kind of own their data set, right?
how do you determine that one data size
Right. Okay. So yeah. So at this point, it's very static because we know the aggregate comes with all the data, and we load all the data. So there's no discriminating of hey, I cannot load this data or not. We load everything in memory, right? So the way we are going to scale it out is we'll just add more nodes, right, to get more memory, right? So if a client suddenly comes up with 100 terabytes of data, yeah, there might be a problem, but that doesn't happen yet, right? Yeah. Yes. All right. 5 minutes. So maybe 2 more questions, and then we'll wrap it up.
I guess
Yep, that's a good question. So how about sort of the DevOps things in aspect of Spark, right? How do you keep, and this area, so that's a very good question, and this is kind of a very evolving field. In Hadoop, for example, you have like nice managers, like you set up install, you can set up alerts. In Spark, this is still like a very evolving part. So we use standalone Spark, and we set up our own scripts to monitor Spark, right? To say if the machines go down, we'll restart new machines and we'll restart new services. It was very kind of manual from our point of view. But to me, it's just a growing pain, right? I mean, as Spark matures, you will have nice installers, nice monitoring systems that come along. But right now, it's kind of bare. It's kind of bare, right? You're right. Yeah, it's kind of very plain right now. Yep.
So,
good question. So I mean, what if I don't save data back and if Spark crashes? That's okay. I can recompute in a flash, right? So yeah. And Spark has all these things built in as well. If a node crashes, whatever data it had will be recomputed on other nodes, right? So yeah. So Spark does the same thing.
is it less capable though than Hadoop?
No, because it still has the same concept of replication. Your data is replicated. So if one node crashes, there's an extra copy somewhere else. Yeah, so all the concepts still apply. Remember, so Spark takes a lot of lessons from Hadoop. So yeah, so they take the data lineage pretty seriously, right? So
And everything is in the memory, right?
I mean, if everything fits in memory, yeah, then yeah, right.
Data replication will be in the memory.
I'm sorry.
Even the data replication will be in the memory.
It can be, yeah. So your data can replicate in memory and also in disk, right? Exactly, and you can control all of this. All right, guys, one more question and we'll sort of wrap it up. No, RDD is more like it stands for resilient. Yeah, exactly, resilient. Sorry, I know you've been trying for a while, so yes, let's get you. Yep. Okay, so good question. Question was Elastic Spark, as in like, for example, question was Elastic Spark. For example, let's say I have a 10-node Spark cluster, and suddenly my demand spiked. Can I automatically scale to like 30, right? Amazon has this Elastic Spark scripts, right? But I mean, our cluster is static. We have an experiment with like the dynamic up and down thing. It should be possible theoretically, right? Because Amazon has Elastic, just like EMR, Amazon has Elastic Spark as well. But I haven't worked with it. Yeah, so theoretically it should be possible. All right, guys, that's it. So I'm going to wrap it up. Thank you so much, and I'll be around for a while. Come and ask me any questions. All right, thank you.